Boy howdy, here it comes. Oh, I hope you got your algebra just a kicking today. We're departing into calculus algebra. Here it comes. Let's go. We're going to find the derivative of e to the x plus y set equal to x squared minus y squared raised to the 1/3 power plus 1. We want to find the derivative on y with respect to x. You're not going to solve for y explicitly, so we're going to do this the implicit method. This is a lot. This is a level 9. Level 8, I don't know. There's not really tricks in it as much as just it's long, and this is going to get disgusting. Let's go. So we're going to take a derivative on e to the xy. So when we take a derivative on e to the blah, you leave the blah alone, and then you multiply by the derivative of blah. The derivative of x plus y is, the derivative of x is 1, the derivative of y is equal to the derivative of the y. We'll be solving for that in a little while. So boom, we've taken care of the left-hand side. No big deal. Now we take our 1/3 power. We're going to let that one fall to the outside. We're going to leave the interior alone, and we make sure not to forget that we need to do 1/3 minus 1, which is negative 2/3. Once we got that, we now need to multiply by the derivative of the interior. The derivative of the interior for x squared is 2x. The derivative for negative y squared is negative 2y. Oh, said derivative and y in the same sentence. We better put in dy dx. Clean that up so it's going to be legible. Cool. Now we say the derivative of 0 is 1. All right. Phew! We did it! Yeah, I took that derivative. Dope. Now solve for dy dx. By the way, this cannot be broken up. That can't be broken up at all. So this is going to need to come in and hit here and hit here. We're going to need to take our e to the xy and bring those two things in as well. Do you see how much writing there's going to be? Let's go. So we get e to the x plus y times 1 is equal to e to the x plus y. Now we have e to the x plus y times dy dx. Cool. Parentheses are gone. We like that. Now we're going to take this monster and we're going to multiply it by 2x. I'm going to put the 2 and the 1/3 together, 2/3. And I'm going to slap the x out front and then multiply it by x squared minus y squared to the negative 2/3 power. Minus. Now we're going to take it and bring it all the way over here. So let's put the negative 2 and the 1/3 together. So negative 2/3. I'm going to slap the y out front. And now, actually the y dy dx. Now I'll put in that x squared minus y squared to the negative 2/3 power. Holy moly. And that was just to make it to where we could solve for dy dx. So there's a dy dx on this side. There's a dy dx on this side. Which way do you want to take it? Which way do you want to go? Do you want to bring stuff over? So I'm going to take this one and move it over to the other side. And I'm going to add this one and bring it over. I like positive numbers. Even though it's a lot of writing, I don't give a shit. I don't give a shit. I'm doing it. Doing it because it's a big problem, right? We're gonna have to add this back over, and look, I'm even writing all this stuff for you. You can see it, what's happening. I don't know if it makes any sense, but these are long. You know how easy it is to make just a little brain fart and screw something up. And the problem is this large. It's incredible. So there was that added over. This stuff canceled, and we're left with that e to the x plus y times the dy dx. So now we have all of our dy dx's on one side. It's right here. And now what's over on the other side? So we still have this piece. That didn't go anywhere. That's 2/3 x times x squared minus y squared to the negative 2/3 power, and then we subtracted this over. Well, why don't we go through and factor out that dy dx? Since it is separated out by a plus and those pictures match, let's cheat. You have a pencil, don't you? We're going to take a dy dx, we're going to factor it on out to the front, put a big old parenthesis, and we're going to erase this shit. That's how factoring works, huh? That piece just goes away. We'll put a big old multiplication sign there telling us that that's just one piece. Now the only thing left to do is divide this thing on over and we're home free, huh? No problem, huh? Then we divide that over. I'm just going to write it once. I don't know. I showed you that. My hand's starting to hurt. So we have this as our numerator. After a while, you can start to catch patterns, and it's actually not as bad. And now this is going to become the denominator. As you'd think, once you've done this a couple times. So there is our solution. Clearly that is the solution. Algebra, yeah? Yeah, algebra. Fun stuff. But after you do a couple of these problems from this step, you can just go straight to this step once you see it. But I digress. Let's keep going. And now here's another one. So we're going to do another just beast. We've got sine of x plus y. And we're going to set that equal to x times cosine of y squared. And this thing's going to get ugly. But you know what? Let's find this. Let's go find dy dx. Let's go find it at the point 0, 0. So here it comes. We're like, let's go. All right, more of this. The x's and the y's are trapped inside of a trig function. So, all right, I guess we're doing chains and implicit. So the derivative on sine is cosine. And then we leave the interior alone. And then we multiply by the derivative of x is 1. The derivative of y is equal to the derivative of y. Cool. Shit. We've got a product going on over here. So let's write x and let's write cosine of y squared. Derivative of x is 1. This one's going to be negative sine of y squared. 2y dy dx. Wow, that was a lot. So small. How did so much stuff come from that? So when we put this together, let's put the negative 2yx, or negative 2xy. When we put that together, and then write in the sine of y squared, dy dx, and then plus, oh, that's not so bad, plus cosine of y squared times 1. All right, so we're sitting there and we're looking like, dang, there's a dy dx right there, and there's a dy dx right there. All right, well, let's start solving for it. And then I would try and reach through the frickin' computer and slap your hand and be like, absolutely not. Don't you dare do that. Didn't you see what frickin' happened back here? That was terrible. That was frickin' awful. Dude, they gave you x and y. Saying, add x equals 0. Add y equals 0. Start plugging in frickin' 0. Everywhere you see an x and a y, start plugging in frickin' 0 and solve for dy dx. Given a point, this is beautiful freaking news. You're like, I ain't got to do any more algebra. So here it comes. We're like cosine of 0 plus 0, which is frickin' 0, times 1 plus, or cosine of 0 is 1, but 0 plus 0 is 0, sorry. And then 1 plus dy dx, and now we got negative 2 times 0 times sine of 0 squared, which is 0, times your dy dx. So that's 0 times 0 times 0 times dy dx. And then we get cosine of 0. So cosine of 0 is 1, so we're left with 1 plus dy dx is equal to, well, all of that shit goes away because 0 times anything is 0. And cosine of 0 is equal to 1. We subtract over the 1 and we find out that dy dx evaluated at 0, 0 is equal to absolutely nothing. It's equal to nothing. 1 minus 1 is equal to 0. The moral of that story is if you're given a point, just take the derivative, leave that bullshit where it sits, and then plug in those numbers and solve. That is much easier than that crazy-ass stuff we were doing of expanding and moving around. So be lazy. And by I say being lazy, take a second to look at something, figure out what you're trying to solve, and try and establish a game plan. Don't waste your time. Don't waste your time. We want to be efficient. So. All right, our next one, we're just going to start seeing a couple little trickier games too, but good stuff. See you soon.